Hello everyone, let's do difference quotient extension. We're going to go now from, we were just doing parabolas, now we're going to do some cubics, and I'm going to help you find the local maxes and mins. So let me, before we get too far into this, show you what the goal of this exercise is. I'm going to bring up Desmos, and I might already have it, x cubed minus 6x squared, this guy, okay. If I said graph this, we are pretty capable of finding x-intercepts. We won't need to do this. These are not nice x-intercepts. But we have talked about finding the x-intercepts. One thing we have not done is talk about finding these turnaround points. So in order to find these turnaround points, what you need to do is you need to figure out where the derivative is 0. So I'm going to bring that up again in a second. I want to know where the derivative is 0, and I know the y-coordinate is 8, so it would be y equals 8. That's where you have a horizontal line. That's the turnaround point. If you think these tangent lines follow along this function, when it gets to 0 is when it's a turnaround point. So that's going to come up in a minute. In order to do this, you need to find the difference quotient, and I'll help you with the setup, and then I'm going to do a little sidebar here. So for the setup, remember for difference quotient, this is a plus h cubed minus 6 times a plus h squared minus 15. That's f of a plus h minus f of a would be a cubed minus 6a squared minus 15a. Now, because I'm going to have to do this in pretty much every problem, I'm going to take a little minute here and I'm going to figure those things out. If I do a plus h squared, that's times itself. And we've done this. It's a squared plus ah plus ah, and then ah. Okay, a squared plus ah plus h squared. So that's a squared plus 2ah plus h squared. That's this. Now I'm going to need to do it again times a plus h. So to expand this now, that's a cubed plus a squared times h plus 2a times a would be 2a squared, and that's got an h, plus 2a h squared, 2ah times h is 2ah squared, and then a times h squared, and then h squared times h is h cubed. So it looks like we have some like terms, a cubed plus a squared h and a squared h. 1a squared h plus 2 more is 3a squared h's. 2ah squared and 1ah squared makes 3ah squared, and then I have h cubed. So we need both of those, okay? This is your squared. Maybe I'll just copy that so I have it. And then this is your cubed, when you have that binomial cubed. Okay, I'm going to need both those. So the first one right here, that's this guy. Expand that out, I get that. These are going to be messy, just so you know. It's going to take a lot of space. It's the first one, and then it's minus 6 times this guy. That's the second one. Woo. Now I just got to distribute the rest of that. So minus 15a minus 15h minus a cubed plus 6a squared plus 15a when I distribute. And remember, this whole thing is over h, but I'm kind of just ignoring that right now because there's just so much. I need to keep going. This is going to get better. A cubed plus 3a squared h plus 3h squared plus h cubed. Now I'll distribute the 6. Minus 6 times 2 is 12. And negative 6 h squared minus 15a minus 15h minus a cubed plus 6a squared plus 15a. Okay, now, when we first started these, I told you that those terms should always cancel out. These three should be going away. So hopefully that gets rid of 6 terms total. A cubed, bye-bye. All right, better. Good. 6a squared, yes. 15a, good. Okay. Now, I have 3a squared h plus 3ah squared plus h cubed minus 12ah minus 6h squared minus 15h. All right, better. And that's all over h. Now, first thing I'm going to do is in the numerator, notice how everything has an h. I'm going to factor that out. Now it's 3a squared plus 3ah plus h squared minus 12a minus 6h minus 15. and that goes away. All right, so I have this guy. Now, there's some magic going on here where we're kind of doing calculus. But what I'm going to do is say, look, when you get to here, anything that has an h, I'm going to ignore. Bye, 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 bye. All those I'm going to ignore, and I'm going to rewrite this with an x now. So 3x squared minus 12x minus 15. And I'm going to call that my derivative, okay? Again, we're kind of doing calculus. I cancel out those h's, but then I'm also going to cancel out any term here that has an h. So basically saying if it's an h squared or more, it's gone. That's what we've got. This is our derivative. What I'm going to do now is I'm going to figure out where the derivative is 0, because that's where we'll find our turnaround points. So I'm going to factor this thing because it is nice and factorable. X squared minus 4x minus 5. I'll ignore the 3. And the numbers that multiply to negative 5 and add to negative 4 are negative 5 and positive 1. It's a 1x squared, so I can do that quickly. That means my zeros for the derivative are at 5 and negative 1, which should tell us that if I were to graph this function, this would be negative 1 something, and this would be 5 something. And I have the graph right there. Look, we found the x-coordinate, negative 1, and we found the y-coordinate, 5. To figure out the y-coordinate, we have to go back up to our original function and plug in those values. So I'm going to take this guy, just so I can see it, and I'm going to plug in those values. I'm going to plug in 5. F of 5 is 5 cubed minus 6 times 5 squared minus 15 times 5. And I'll do f of negative 1. Negative 1 cubed minus 6 times negative 1 squared minus 15 times negative 1. Now, you can use your calculator for this. I think I know what the answer should be. 5 cubed, no, minus 6 times 5 squared minus 15 times 5. When I plug in 5, I get negative 100, negative 100. And when I plug in negative 1, make sure you use parentheses, especially when it's negative. Cubed minus 6, negative 1 squared minus 15 times negative 1. When I plug in negative 1, I get 8. And look, that is the y-coordinate for the other one. So I just found the two turnaround points. I'll go through it again. What you're going to do is you're going to do the difference quotient. It's a monster of a difference quotient. That's okay. It's just algebra. It's just a lot of algebra 1. You can do that. Then you will get to a point where you factor out an h, that goes away, and you look at what's left, and you say, you know what, if it has another h, it's definitely gone. So this one's gone, this one's gone, this one's gone. 3a squared, negative 12a, minus 15. That is called your derivative. We want to know where the derivative is 0 because the tangent lines have a slope of 0. They're horizontal. They have a slope of 0. So I set the derivative equal to 0, find where the derivative is 0, and then you go back, plug in those ordered pairs, or plug in the x's to get the ordered pair, and you should see, once you have the x, you should be able to find the y. Okay? You can do this. I'm going to do one more, and you could try the last one. Oh, I didn't use those steps. Okay. So because I just did this, I'm not going to write it out again. I know what it is expanded. It's a cubed, maybe I should write the substitution step, 2a plus h cubed plus 3a plus h squared minus 36. There's f of a plus h, and now I'll subtract f of a. Okay. Now, like I said, I already expanded this, so I'm just going to write out what it comes out to. It's a cubed plus 3a squared h plus 3ah squared plus h cubed. That's this. Plus 3, I know that one too. A squared plus 2ah plus h squared. That's this. Okay. Now I just got to distribute the 36. Then it's going to be distribute the negative. Minus 2a cubed minus 3a squared plus 36a. Remember, this whole thing is over h, but I'm not ready to get that far. I'm just going to keep going. Distribute the 2. Distribute the 3. The rest is not going to change. minus 36a minus 36h minus 2a cubed minus 3a squared. Okay, they're long. But again, these should all cancel. So hopefully I can find a positive 2a cubed. Yeah, I got one. Good. Hopefully I can find a negative. I have a negative. I find a 3a squared. 3a squared. 36a. Good. Better. Okay. Now I'll factor an h out of the terms that are left. So this guy has an h. 6a squared plus 6ah plus 2h squared plus 6a plus 3h minus 36. If you don't do this step, you will lose some terms. Don't try and do it in your head. Factor out the h. Okay, now look at this. Anything that doesn't, or anything that has an h goes away. H. F prime of x is 6x squared plus 6x minus 36. I got my derivative. Now, set it equal to 0 because the slope will be 0 for a tangent line. If it's passing, or if it's at the turnaround point. What multiplies to negative 6 and adds to 1? X plus 3, x minus 2. So, I should find my turnarounds where the x-coordinate is negative 3 and the x-coordinate is positive 2. To find the y-coordinates of those turnarounds, I need to plug it back in to this function. Can I just steal this? I can't. Good. Okay, so I need to plug those values into this function. So 2 times negative 3 cubed plus 3 times negative 3 squared minus 36 times negative 3, and 2 times 2 cubed plus 3 times 2 squared minus 36 times 2. So if I plug those in, here's my calculator. 2 times negative 3 cubed plus 3 times negative 3 squared minus 36 times negative 3. So when I plugged in negative 3, I got 81. That means the ordered pair for the turnaround point should be negative 3, 81. That's one of them. I'll do the same thing for the other now. 2 times 2 cubed plus, nope, stop that. Plus 3 times 2 squared minus 36 times 2, and you get negative 44. Negative 44. So when you plugged in 2, you get negative 44. That means the other turnaround should be at negative 44. Now, I got to graph this one. I think I might already have it done. It's the 2x cubed, this guy right here. So let's see, where are the turnaround points? I said they should be at negative 381. Let's go. And the other one, 2, negative 44. All right. Okay, so one more time. You find the difference quotient. It's long. You factor out your h. You ignore any term that has an h. That creates your derivative. You set the derivative equal to 0 and solve. Those should be easily factorable because I created friendly problems. You find the x-coordinates of the turnaround points. To find the y-coordinates, you plug them in, and then you graph it to check. Okay? That's pretty much calculus, folks. If you can do this, you're in good shape. So, smash that like button, smash that subscribe button, and try that third one.